Welcome to Daikin web-based training. In this course, we will learn about the key points of installing refrigerant piping using the VRV3 heat pump system and R410A refrigerant as an example. Let's go over what we will be learning in this course. We will look at refrigerant piping with regards to 1. The 3 basic principles of refrigerant piping, 2. Handling, 3. Installation, 4. Supports, and 5. Insulation. When installing refrigerant piping, be sure to always apply the following 3 principles. The first is dry. Water and moisture must be kept out. The second one is clean. Dust and contaminants must be kept out. The third one is tight. Refrigerant must not leak. When the 3 basic principles are not applied, it will prevent the air conditioner from operating normally and could even cause system failure, and thus significant inconvenience for the customer. So, your utmost effort is required in preventing this from occurring. In order to properly install piping, appropriate handling of the refrigerant piping is necessary, in addition to the installation work itself. In other words, the refrigerant piping must be handled in such a way that no water, moisture or dust can get inside. That is why it is important to cover and protect the pipe ends when storing refrigerant piping. Never place refrigerant piping directly on the floor. Always place it on a table or the like. If it is placed directly on the floor, water, moisture and dust could easily get inside the pipes. Particularly when pushing the piping through a wall, be sure to securely cover and protect the pipe ends. The following covering and protecting methods are to be selectively used according to where the refrigerant piping will be installed and how long the work will take. When it is an outdoor location and the work will take at least 1 month to complete, use the pinching method. When the work will take less than 1 month, use either the pinching or taping method. When it is an indoor location, use either the pinching or taping method. With pinching, the refrigerant piping is closed off, and the gap on the end is brazed. With taping, the end of the refrigerant piping is covered with vinyl tape. The following should be adhered to when installing refrigerant branch piping. Be sure to always install the ref net header or horizontal piping from the ref net joint so it is level. If these are not installed level, it will cause refrigerant drift, which will result in strange noises and prevent normal operation. In terms of vertical piping from the ref net joint, be sure to always install it vertically. If the piping is to be bent before or after the ref net joint, bend it at least 1.6 feet away from the ref net joint. This is because bending the pipe too close to the ref net joint can result in strange refrigerant noises due to turbulent flow, leading to customer complaints. Moreover, it is necessary to create a straight section of at least 3.3 feet between ref net joints. Be sure to install the outdoor unit connection piping kit horizontally. If this is not done, it can cause refrigerant drift and prevent normal operation. In order to prevent refrigerant drift, create a straight section of at least 20 inches before the first branch. Install refrigerant piping so that refrigerant oil does not build up inside. To do this, install refrigerant piping horizontally, or with an upward gradient toward the outdoor unit. If oil builds up inside the piping, it will prevent oil from being distributed evenly in the system. When the distance between 2 outdoor unit connection piping kits or between a connection piping kit and an outdoor unit is 80 inches or more, install a rise of at least 8 inches only on the gas pipe. Branching like this would result in oil buildup when the system is off. Be sure to branch the piping as shown in the diagram on the right. When an outdoor unit must be installed in a lower position for some reason, install a rise of at least 8 inches before the piping goes downward to prevent oil buildup in the outdoor unit. For vertical piping with a large level difference, take the necessary measures to prevent buckling. Also, create a space to compensate for changes in the size of the piping due to thermal expansion. The insulation material will shrink over time, and if the piping is supported from above the insulation material, the piping supports will loosen and the piping itself will slip further downward as the level difference increases in the VRV refrigerant piping. Moreover, The repeated expansion and contraction of the refrigerant piping, due to temperature differences, will lead to the load on the vertical piping being concentrated at the very bottom, eventually causing buckling. In order to prevent the piping from slipping downward and direct the thermal expansion-contraction upward and downward, connect this type of support directly to a copper tube in at least one spot at the midsection of the vertical piping. The temperature of refrigerant piping can be quite low, so support it from above the insulation material to prevent condensation. When doing so, be sure to prevent the insulation material from being crushed by the weight of the piping. If the insulation material gets crushed, it will decrease the effectiveness of the insulation, causing water to leak. As shown in this photo, insert a polyvinyl pipe and insulation tape between the supporting fixture and insulation material to avoid crushing the insulation material. Do not use piping to support other piping. If this is done, the piping will place further load on the support part. In order to prevent sagging or vibrating of the piping due to its own weight, the support intervals for the horizontal pipe should be within 5 feet, if its outer diameter is up to 3/8 of an inch. If the outer diameter is half an inch or more, the support intervals should be within 6.6 feet. If the liquid and gas pipes are suspended together, the support intervals should be based on the size of the liquid pipe. Moreover, the support intervals for the vertical pipe should be within 5 feet. Support the ref net joint at 3 points to maintain levelness. Place the supports between 1 and 1.6 feet from the center of the ref net joint. Place supports for the refrigerant piping so that there is no direct load on the connection area with the indoor unit or the through-hole area on the external wall. Around the indoor unit, for example, install a support at least within 1 to 1.6 feet from a flare connection to minimize the load on the connection. Also, install a support within 1 to 1.6 feet up, down, or left, right from the through-hole to prevent the waterproofing, such as caulking, from being separated from the through-hole or piping due to contractions and vibrations of the refrigerant piping. Let's now learn about the insulation work. As there are no tests to confirm insulation work, sealing the seams of the insulation material and the like should be done carefully. Install the insulation so that there are no gaps between the insulation material and the piping. Use insulation material that can sufficiently withstand the temperature of the refrigerant piping and complies with the local regulations regarding fire prevention and the like. For the heat pump type, use heat-resistant polyethylene foam that can withstand heat of at least 248 degrees Fahrenheit. For the cooling-only type, use polyethylene foam that can withstand heat of at least 158 degrees Fahrenheit. Conduct the insulation work on all the connections after the system passes the airtightness test. In order to prevent condensation, if the temperature and relative humidity around the refrigerant piping may exceed 86 degrees Fahrenheit and 80% respectively, the insulation must be at least 13/16 of an inch thick. There are some regions where fire ordinances and the like prohibit the use of polyethylene foam insulation. Therefore, confirm those regulations prior to doing the insulation work. Insulate the gas and liquid piping separately. In consideration of how the insulation material will contract over time, apply a special adhesive to the cut surfaces of the insulation material and seal them with insulation tape. Specifically, first apply the special adhesive to stick the pieces of insulation material together. After this, wrap wide adhesive tape around the areas that have been cut. When inserting insulation material to fill a gap between the insulation materials, cut the material so that it is 8 inches longer than the gap. The insulation material will contract over time, and this is done to prevent the gaps from reopening. Try to minimize the number of cuts in the insulation material. For example, when reinforcing the insulation material near a bend, stretch the insulation material up this way. This allows it to be reinforced in just one place and saves time and effort. If the insulation is sealed at a bend, it may become deformed and cause the insulation to be insufficient. Therefore, be sure to reinforce the insulation in a straight area. Make sure there are no gaps in the seams of the insulation material. Also, do not use damaged insulation material. This photo shows a gap in the seam of the insulation material, resulting in condensation and water leakage. If the insulation material is torn by hand, where it was torn will be uneven and lead to gaps in the seam. When cutting the insulation material, use a sharp utility knife so it can be cut straight, before sticking an adhesive on the surface. This photo shows what happens when piping is forced into a narrow area, resulting in the insulation material being torn in several places. Do not use insulation material in this condition. Replace it with new material.